Hi guys, so in this video we are going to learn about conic sections. It's an introduction of what conic sections are, how those things are useful, how these curves are useful, and where does it come from, right? So conic sections are the curves, right? So these four curves are called conic sections, which is circle, ellipses, parabola, and hyperbolas. These curves are called conic section. There is a reason why they are called conic section, because they are obtained when a plane is intersect with a double napped right circular cone. So when a plane intersects with a double napped right circular cone, it gives you one of those curves, right? So we are going to learn more about what this double napped right circular cone is and what intersections are we talking about, right? So what are the applications? Why conic sections? Why do we even learn about conic sections? Because these curves have a wide range of applications in the field of planetary motions, right? Design of telescopes, antennas, reflection in flashlights that happen, or the reflections in automobile headlights. So in all these things, if you think, now that you know, if you think about these things, you will automatically see there is a cone somewhere there, and there might be some intersections, and that is why these things are important, right? Otherwise, by the end of this video, I'm sure you'll be able to visualize how these cones and how these conic sections are important and used in our everyday life, right? So sections of a cone. So first let's understand where is this cone coming from, right? So there is a straight line L, right? And there is another line which is intersecting L at an angle of alpha, and we have named it as M, right? So we have three things. We have a main fixed vertical line, which is L. We have another line, which is M, right? It is intersecting at an angle of alpha, right? So what we do when we have these three things ready, we rotate the line M. We are rotating the line M such that the angle alpha remains constant. So what we are doing is we are rotating this M, all right, this way, so the angle remains constant. So this is rotating, and here it will be rotating this way as well, right? So it is rotating, so the angle alpha remains constant, right? It's all angle alpha here, okay? So it's rotating that way, and that way when we rotate it, we are able to find a double napped right circular cone. All right, in this video, or usually it is just called a cone, but it's double napped because it has two pieces, and each of those things are called naps, right? Okay. So yeah, this is really important to understand where is this cone coming from and what are the parts of this cone, because we are going to talk a lot about the parts, these parts and these names, when we are learning about the curves individually, like circle, hyperbolas, parabolas, and ellipse. When we are learning about those curves individually, we are going to use these vocabulary as well, right? Vertical line and the other lines and stuff, they have specific names, which is here. So here, vertex is this point in the middle, it's vertex. L is the line, the axis, all right? The main line, the fixed line is L, it is axis of the cone. And M, the slant line that was rotating, is called a generator, all right? Because that generates. Then there is an upper nape, there's an upper nape, and then you have a lower nape as well, okay? So this is the vocabulary or parts of this double napped right circular cone, okay? Now next is, how do these intersect in planes? So if we take the intersection of planes with the cone, the section obtained are called conic sections. So now we're going to have a plane surface or plane, all right, and we are going to intersect that plane with this cone. So we obtain different type of these conic sections, all right, with different angles, with different planes. So position of the plane. So depending on the position of the intersecting plane, right, with respect to the cone, and the angle made by it with the vertical axis gives us different conical shapes, right, different of these curves. So how we get it? Let's go there. So when the plane cuts the nape, right, other than the vertex, because if it is cutting the vertex, it's just here. If it cuts the vertex, it's just going to give us a cone, right? It's just cutting here, it's just two cones, right, two napes. But if it is not here but cutting somewhere else, all right, we have the following situations. So the first situation is that your angle B is your angle of the plane, right, or beta. So beta is your angle of the plane. So if the plane is 90 degrees, the section that is formed is called circle, right? So I have the shape here. So here, this one here. So if you have a cone, right, so that is your naped cone, and we have the plane. So this is your intersecting plane, right? It is 90 degrees. So this angle is 90 degrees here. This beta angle is 90 degrees. The section which is formed in there is your circular section. Okay, so that is your first conical section, is the circle, right? The second is when your beta, the angle of the plane, all right, beta is greater than alpha, okay, and is less than 90 degrees. All right, so it's not 90 degrees, but it is greater than alpha. Then the curve formed is called ellipse. So it's that one. It is greater, but not more than 90 degrees, right? If it is 90 degrees, it's going to cut vertically. But in this case, you are formed with an ellipse, okay? Next one is if alpha and beta are both same, you get a parabola. If your alpha and beta is same, you are cutting it that diagonally and you get a parabola. And the last one is if your beta is greater than equals to 0, like greater than 0 but less than alpha. So in the first one it was greater than alpha, but now it is less than alpha. Then you will get a hyperbola. All right, so let's look here. So it is less than alpha but greater than 0 degree. You get two curves in both the napes because it is cutting in that angle that the plane can pass through both the napes, and you get a hyperbola. All right, so these are the four cases we are going to learn more about in our coming videos, and in the coming video I'm going to explain each of these conical sections separately with their equations and with their applications and some exam questions as well. All right, so stay tuned, and this is the introduction. I hope this is helpful. If it is, then leave a comment below. Have a good day.